On that Monday, Tuesday, I'll do help session probably. So we should be, where the hell are we? 134? 134 it is. Okay. Ooh. Really zoomed in. So again, we've actually drawn the free body diagram of this. We did it when we did the free body diagrams way back when. And you can see if I draw the free body diagram, the whole thing, it would kind of suck because I cut through a cable, that's one unknown, cut through here, that's two unknowns, that's three. Come around, cut through there, that's four, and back around. So I would have two here, two there, and one there, that's five unknowns. Not a good deal. So the best thing to do would be to break it up into pieces. Or if you look at what we said, step one of a frame is, if possible, solve for the support reactions. Well, hell, is it possible? Nope. So what are we going to do? Dismember it and go to step two, dismember into pieces. And we're going to dismember it into piece A, B, C, and D, C, E. So we're going to bust this up into here and into here. So I have a free body diagram of ABC, and I'm going to have a free body diagram of DCE. DCE will look like this, where I will have an EY and an EX. Of course, I have this single force of 500 sitting up here. I will have, it says bar AC weighs 100 pounds, bar DE weighs 50 pounds. So I will have a at G 50 pounds. And then since basically this is sitting on top of there, like so, that point is pushing up, and then this thing is pushing down on it, I should have some sort of force perpendicular here that I'm going to call FC. And I can find this angle. This theta is tangent inverse of 2 over 3. So theta is equal to 33.69 degrees. Over here, we'll have that horizontal surface. I'll throw in a T. I'll throw in a BY, EX. I have a distributed load that I cut through. I reduce that down to a single force, which is 1,000. Acting, 2.5 here, 2.5 there. And then, of course, we're going to put in the weight at G, which in this case is 100. And equal and opposite, I have to have this FC, NC, whatever you want to call it. And this sits at 2, 3. This sits at 2, 3. Please notice it's 3 horizontal, 2 vertical, but you need the complement of that, which is 2 horizontal, 3 vertical. Now, before you go off writing equations, make sure you have enough unknowns and enough equations. 1, 2, 3, 4, counted, 5, 6. there are 6 equations, and there are 6 unknowns, 3 per free body diagram. Agreed? Where do you want to start writing equations? ABC or DCE? Why? You know it's going to have a why. There's only 1, 2, 3 unknowns here. I can get them all by writing in some force x, some force y, and some moments. Over here, there's 1, 2, 3, 4. So I'm going to need FC from here to bring to there so that I can reduce it down to 3 unknowns. So the best place to start would be DCE. What am I going to do first? Moment where? Yep, beautiful answer. Some moments at E equals 0. Clockwise, positive. That's 3 times FC minus 50 times 5 cosine 33.69. And you say, how the hell did you do that? Well, here's its line of action. Remember, this is a total of 5 feet this way, 5 feet that way. Right? To G. So it's 5, and then I have this basic triangle. It looks like this. That's your angle theta. You're looking for this distance. If this is 5, that's going to be 5 cosine of theta. So that's where I'm getting the 5 cosine of 33.69. Minus 500 times, again, I'm looking at what is this horizontal distance to E. That's going to be 10 cosine 33.69. All that must equal 0. If you do this, do the math, FC comes out 1456.16 pounds, of course. Some forces in the x equals 0, positive to the left, that says EX minus 2 over 3.606 FC equals 0. Oh, you went with slopes. Yeah, I'm flipping back and forth now. So it's a 2, 3, and the hypotenuse is 3.606. So if I want the cosine or the sine, I just say the 2 over 3.606 or 3 over 3.606. Right? Or I could just say sine and cosine of 33.69. Same thing. I dump this in here, EX will come out. 806.72. Some forces in the Y, positive upward, equals 0. That's going to be EY minus 50 minus 500 plus 3 over 3.606 times 1456.16 equals 0. EY comes out 661.45. You asked me to find all the reactions. I'm doing that. I'm finding all the reactions. I just found FC. I found EX. I found EY. So I can now take FC, making sure that it's equal and opposite, and dumping it over here, 1456.16. So I'm basically taking this sucker and taking it over. That's that working back and forth. I'm gonna do some moments about B equals 0. Counterclockwise positive, 1,000 times 2.5 minus 100 times 2.5 minus 3 over 3.606 times 1456.16. Remember, this guy has two components, one in the y, one in the x. That x is gone because its line of action goes through b, so I'm doing the y component. This right here is 4, 5, and 6.403. So now I'm going to come in and I'm going to write 5 over 6.403 times t times 5 equals 0. What? Yeah, I'm adding this. So T comes out 26.8 pounds. And now just simply come in and say some forces in the x equals 0, positive to the right, that says bx minus 2 over 3.606 times 1456.16 minus 4 over 6.403 times 2526.8 equals 0. Bx is equal to 2386.14. I'm all getting positive answers, so everything is okie dokie as far as my directions. Some forces in the y equals 0, positive up. That says by minus 100 minus 1,000 from the distributed load minus 3 over 3.606 times 1456.16 minus 5 over 6.403 times 2526.8 equals 0, or by is equal to 4284.6. Voila. Notice that we basically took this whole thing and dismembered it into two pieces. We did a problem way back when. This problem, same idea, except this was a two-force member. If I recognize that, I'll make my life much easier. One free body diagram instead of two. Oh, sorry. This is one that we did right after we discussed two-force members. You recognize this as a two-force member, you're home free. Because all I have to do is draw one free body diagram and 3 equations. If I do 2, that's 1 and 2 free body diagrams, then I'm down to writing 6 equations instead of 3. So recognizing two-force members is a huge benefit to you. And you'll see I throw in two-force members a lot when it comes to frames. Problem number 3 on test number 2, which is going to bite you in the ass because it's coming right after a break. So taking the entire week off is probably not a good idea for you, since that test is coming the week we get back. I ain't saying you gotta study every single day. I do want you to have a little bit of fun, but at the same time, your grade's gonna hinge on the next test. And it's coming at you pretty quickly right after break. Usually, when I give a test after a break like this, grades suck. And if I wait a week after that, the grades are much better. This time around, yours happens to hit right after break. So keep that in mind, make sure you open that book and do some problems, especially trusses and frames, because that's going to be 67% of your test. You have a truss problem number 1, a frame problem number 3, and in the middle, there's a 3D chapter 5 problem. So 67% of your test is what we're doing right now, trusses and frames. And I'm sure you haven't done too many or not enough of trusses, and for sure not enough frames to be in good shape for the test. Yeah? For the moment about what? Where did I get what? Negative 1,000. I got 1,000 times 2.5 minus 400 times 2. Where's the negative? What are you talking about? It's 100. That's the weight. All right. Next problem. Next problem is what's known as a compound beam. Key element, compound beam. So if you look, example 617 is a compound beam. Well, what composes a compound beam? Compound beam is a beam that's not continuous. Somewhere along the span of the beam, there is a hinge, a pin of some sort that connects, in essence, two pieces. The left piece, AB, and the right piece, BC. That's a compound beam. Every beam we've done has been nice, homogeneous, continuous, one solid piece. But if you do a compound beam, you have a hinge or a pin in the middle someplace. Which means I can unscrew this pin, pull it out, and separate this into two pieces. If I don't have that pin, notice what happens. Forget the pin. I have a rocker, that's 1. And then a fixed support, that's 3. 3 plus 1 is 4. 4 unknowns, I can't solve this problem. That would make it a statically indeterminate problem. With the pin in the middle here, at B, I can separate it into two pieces, like you see. He's in essence separated into two pieces. And for the pin, he's put in a BX, BY equal and opposite BX, BY. He's got the CY, now he's got 1, 2, 3, 4, 5, 6. So now it becomes a solvable problem as opposed to one solid beam with a rocker or roller at the end becomes statically indeterminate. This is not a statically indeterminate problem. Again, statically indeterminate is a hell of a lot more common than you think outside the real world. That is why the next class, Mechanics of Materials and Mechanics of Solids, is so essential. It is a very big deal. And a lot of students do not do well in Mechanics of Materials and Mechanics of Solids. Part of the reason, they did not get a good base here. Yeah, they got their C or C+, but really didn't learn it well enough to transfer it over to Mechanics of Materials and Mechanics of Solids. As a matter of fact, In mechanics of solid, there's 5 things you've got to know. Equilibrium is 1. That's chapter 5 here. Right? Second, you need to know centroid. We're going to get to that after the break. You're going to need to know area moments of inertia. We're going to get to that after the break. You're going to need to be able to draw shear and bending moment diagrams. We're going to get to it after the break. That's 4 things from statics. And then the 5th is mechanics of materials. You use the equation of mechanics of materials to solve for the entire problem. But 4 out of the 5 steps are all statics. So when I tell you, hey, you really got to get a good foundation here, or you're going to pay the price down the road, I'm not lying to you. I haven't lied to you all semester. Why would I start now? Okay? So for sure, try to look at 617. Make sure you understand, or maybe even just cover this up and try to do it again on your own. Count that as one of your 5 problems per day. This one right here, the first thing I notice is a compound beam, which means I have a pin reaction at B, which means I can separate this into 2 pieces, AB, let's call this C over here, AB and BC. But first, I notice a distributed load, which is perfect timing because today's test
quiz
is on distributed load. So it's a nice little review for you. So the first thing I'm going to do is I'm going to take that and reduce it down to a single force at a known location. Which means, for this right here, the rectangle, that's easy, because the single force is going to be base times height, area underneath the curve, which is base is 3, height is 100. That's 300 at, what's the centroid, or the center of the area? That's going to be 1.5 from B. This is number 1. Number 2, this would be the non-uniform load. Single force resultance equal to integral A to B of W of X dx. Well, how much does it stand? It stands from 0 to 4. Integral 0 to 4 of 3x squared negative 3x squared plus 2x plus 40 dx. That's going to be minus x cubed plus 2x squared over 2 plus 40x, evaluate from 0 to 4. Now your evaluation skills kick in. It'll be 112 pounds. Now the question is, where do I place it? Where do I locate it so I get and maintain equivalence? Well, if I take moments at A, I'm going to say x times single force resultance equal to integral A to B x times W of X dx. This is moments of the reduced system equal moments of the original system, which would be x times 112, that's the single force resultant we found, is equal to integral 0 to 4 of minus 3x cubed plus 2x squared plus 40 times x dx. That's 112. X is equal to minus 3 over 4 x to the 4th plus 2 over x cubed over 3 plus 20 x squared, evaluate from 0 to 4. this becomes 170.667. So X is gonna be 170.667 divided by the 112. That's gonna be 1.524 feet. Questions there? That's gonna be on the quiz today. So if you have questions, you better ask now, or forever hold your peace. What's that? Yes, we did that in the pro copy book. You weren't paying attention.
Okay, that makes sense.
He asked me, can I do integration with a trapezoid? Yes, but why would I do it with a trapezoid? That would be probably the long-ass way of doing it. But yes, as a matter of fact, I showed you. You remember this? Here's the area of a trap and the centroid. Got it. I did it using a triangle and a rectangle, and then I did it using triangle and a triangle. Answer is always the same: 541.4, 541.44, 541.44, and then I anticipated you saying, hey, can you do this with a trap? Yes. There it is. I found the equation of the line that represents the trapezoid, which was this. 1333x plus 200. And then I integrated. And what did I get? Same shit. 540, 1.44. So did I answer your question, my son? I showed you this in class. You must have fallen asleep. Did I not show this in class? I rest my case. He's like, damn. Should have paid more attention. Oh, anyway, back to our problem. Our problem was this one. And now, I'm going to break this up into two pieces because I have a compound beam. And I'm going to say this and that. So I'm going to do a free body diagram, AB, a free body diagram, BC. Here's BC. Unknowns of BX, of BY, single force of 300 here, which is 1.5 feet from B. And then I have a cable tension over here at C. On the other side, I have a beam where I have AY, AX, moment MA. I'm going to put in here a BX, a BY. Here is good old Newton's third law. And then I'm going to show this cable tension because I cut through it up here and then I cut through it there. So I got to show it in two places. I showed it here and I got to show it there. And we have to put in our single force resultant from the distributed load, 112, 1.524 feet away. There it is in two pieces. Make sure you have enough equations. I have 6 equations because I got 2 free body diagrams. I better have 6 unknowns. 1, 2, 3, 4, 5. Oh, no wonder I don't add up. 5 and 6. Where should I start? AB or BC? Absolutely. So if I do a quick moment equation, some moments about B equals 0, counterclockwise positive, 2 times T minus 300 times 1.5 equals 0. T is 225 pounds, which means here I'm going to put 225 there. Now I will tell you, when I was in your shoes, I had colored pencils, and I would indicate in a different color, like I did here. I put it in green, 225. That to me is telling me, hey, that 225 did not come from AB. It came from a different free body diagram. It's just my way of recognizing where these damn numbers are coming from. Do a sum forces in the x equals 0 positive to the right, bx minus t equals 0, or bx equals t, but t equals 225, which means bx is 225. So now I can come over here in a different color. 225 is bx. I sum forces in the y equals 0 positive up. That says by minus 300 equals 0, or by equals 300. That tells me this is 300. Again, the green for me is telling me that those numbers are not from free body diagram AB. Once I have that, then I go over to AB and I say, all right, what's the first thing I want to do? Where am I going to take a moment at? Yeah, that'll give me MA right away. Right? Perfect. That's what I want. Some moments at A equals 0. I'm going to take counterclockwise positive. I drop the MA. There's an MA. Drop it in. It's a moment already. Minus 112 times 1.524 feet plus 225 times 4 minus 300 times 5 equals 0. Bam. MA comes out 770.68. Sum forces in the x equals 0 positive to the right. AX minus BX equals 0, or AX is equal to 225. Sum forces in the y equals 0 positive up. That says AY minus 112 plus 225 minus 300 equals 0. AY is 187. All these are in the right direction because I got positive numbers all the way through. Because I'm a great guesser. Questions? Yes, if it's a negative, if I've got a negative 225, I would have carried the negative over to the other side. I would have written it in green minus 225. And if BX was, or BY was 300 negative, I carried, once I draw the free body diagrams and the directions of the unknowns, I never touch the free body diagram. If there's a negative, I just bring it with me to the next diagram. Okay? That negative is telling me the arrows in the wrong direction. Questions? Questions? All right. What? I have a quick answer. No. Never switch the direction. So if I drew these free body diagrams, I've already done that. Because you don't do this until you draw the free body diagrams, correct? So I've got the free body. I get a negative bx, let's say. So I get a negative. Bx is 225 negative. Well, that tells me that this arrow is to the left, correct? Which means this arrow should be to the right. I don't touch them. If this comes out negative, I just carry the negative with me over here. That, in essence, is flipping. It's already automatically flipping when you carry the negative. Say that again? I didn't understand. Some force of X is totally independent. Yep. Yep, that's correct. All right. I want you to see something that is kind of ridiculous. So, this is the Hyatt Regency, Kansas City, which I believe collapsed back, I believe, I want to say 1992 or something like that. So the Hyatt has two buildings, one here, and then there's a walkway in between them. And of course, it's hanging, so there's nothing underneath. So it looks like this. Now, it was literally designed this way. And it was 2 C channels and the pipe, the rod that goes to the ceiling to kind of carry the load. And it was bolted down with bolts. Okay? That's the way it was designed. The engineer designed it this way. The construction people built it this way. That's not the same thing. Can somebody read plans, please? So here, notice, there's a C channel. They followed that. Then they have a rod here, bolt, bolt. Well, if you do a quick analysis, free body diagram. This is how it was intended to be built. This is how it was actually built. If you look where the bolts are at the B. The bolts, due to the analysis, says we carry W over 2, so half the weight. The bolt has to carry half the weight. The way they built it, what's the bolt carry? Entire weight. So it held up for a while, but then of course eventually it's going to give way, and it did. I believe it killed about 120 people. All because of this. Something very simple that you, as static students, could do a frame analysis and see what the loads were. Now, I'm sure what happened was they sent to the construction site bolts that could carry W over 2 with a safety factor. Well, now the bolts were carrying the full weight. Well, you didn't send me the right bolts, in essence. Dollars. money. This is true, but you look at it and say, well, I've already built in a safety factor, I should be fine. And if they did build it the way it was supposed to be built, you wouldn't have had the collapse. But some idiot, and this is why I keep trying to tell you, hey, please pay attention to details. Details matter. Okay? Over here, okay, so you lose a point, you forgot a negative sign. Or you didn't pay attention to the coordinate system, you fucked that up. Or, hey, I got a 40 down, that's a couple. No, it's not. Did you pay attention to what a couple is? 1 down, 1 up. Well, on the test, I gave you 40 down, 40 down. And you know when I was writing that test, I'm like, somebody's gonna fall for this shit. And sure enough, somebody fell for it. More than just one somebody. Just so you know. So when I tell you, please pay attention to details. Here you're losing points, no fucking big deal. In the real world, you're losing lives. That's a big deal. People go to jail for this. So paying attention to details is important. Look it up, Kansas City Hyatt walkway collapse. And we're not talking just that. That's one that is so obvious. It's kind of hurts that it actually happened. We had, I believe, the FIU bridge in Miami fell down, killing some people. Again, the sad part is the bridge was telling them already things are not right. Because as soon as they put it up there, cracks starting to occur in the bridge. You're like going, did anybody not notice the cracks? Like the bridge was telling people, this is not built right. It's going to collapse. Like within the next day, there were cracks in the bridge. Nobody paid attention to that? How do you not pay attention? I can understand you get some cracks 10 years down the road or something, but instantaneously they started getting cracks. Nobody noticed. And so it collapsed. I believe it's right by FIU. Anybody from that area?
Right there.
Isn't it like 5 lanes across or
Yeah,
something?
basic structure, but 9 people died.
9 people died. You're lucky 9 people only died. Really? I believe it's a walkway, isn't it?
Yeah.
That goes from
Walkway.
one side of campus to the other?
Yeah, and then there's cars under. So
Yeah.
The bridge also still on cars.
Yeah, correct. Yes, not a good way to go. Yep, that's another one. The Surfside condos in Miami. That was huge. The condos are, yeah, they're just squeezed the condo industry pretty bad. Anyway, so keep that in mind. Let me do another. This is from the help session.
Wait, I thought we were not doing help sessions.
So the mechanism is used as a gate to open and close, thereby allowing water to flow out between B and C. So this sucker kind of bends over, this opens up, water comes through. All right? Determine the resultant force and location of the distributed load, which is again something that you have to do. Forces at pins A, B, D, and the roller C. You don't see a roller, but when I have an object just pinned against something, basically touching, that in essence is a roller. Okay? So the first thing we're going to do is we're going to see this trapezoid. It looks like this. And I'm gonna break it up into area 1 and area 2. Single force resultant of 1 is gonna be 1/2 times 3 times this distance. Well, that's 30, and that's 74, so this distance is actually 44, and that's 30. So if I come in here and do this, this will be 30, this has to be 44 to lead me to 74. So this has to be 44, and that would mean this is 66 at 1 meter from C. Remember, for a triangle, it's 1/3 of the base from the fat end, or 2/3 from the skinny end. The base is 3, right? So from this fat end over here, it's going to move over 1 unit. The next one is basically a triangle, a rectangle. Single force resultant 2 is base times height. That's going to be 3 times 30, which is 90. And where's it acting? At 1.5 from C. If I sum these two, what's my single force resultant going to be? 156 pounds is the single force resultant. Where does it act? Well, I got to set the moments equal to each other, right? So I'm going to say x times 156 is equal to 66 times 1 plus 90 times 1.5. X is equal to, somebody got a quick calculator? What is it? Where are you? I see, I hear a voice. I'm like, where the hell is this voice? What'd you say? 1.288. Verification, please. I need a safety factor of another student. 1.288. Beautiful.
Oh, I need it.
Now, it asks me for it. If it doesn't ask me, I can just use the 66 and the 90, and knowing the distance, I can proceed. So I can do single force, single force, and a single location, or I can just use these two and not worry about getting down to a single force. In other words, I can draw the free body diagram of A. Oh, and by the way, what do you see here? B, and this thing right here, let's call it E. What do you see there? What do you see here? What is that? That's a two-force member. So, free body diagram ABC is going to look like this. I can say there's an AY, AX. Again, these are arbitrary in direction. I have some sort of force FBE, which is the two-force member. I have a single force 90. I have a single force 66. And I have a normal force. Let me extend this out. I have a normal force NC. These are 1 foot away. This is 1.5 feet away. I could do that, or I could draw a free body diagram, or I could just say AX, AY, single force FBE, single force 156 acting 1.288 away from C, the normal force. I could do this or I could do this. So if you don't want to take it, if it doesn't say take it down to a single force at a known location, then you don't have to. You just leave it 90 and 66 at those locations of 1 and 1.5. You'll still get the right answer. And then over here, I'm going to draw this free body diagram. Free body diagram, DE in essence. That's this guy that looks like this. I have 15 kilonewtons this way. This is 15 kilonewtons. I will have a support reaction, which is D, dx, dy. I will have a single force, FBE, from that two-force member. These, of course, have to be equal and opposite. They are. And now, where do you want to start writing equations? I'm going to do DE because it's got 1, 2, 3 unknowns. Perfect. I'm going to do a sum moments about D equals 0, clockwise positive, 15 times 3 minus 1.5 times FBE equals 0. Or FBE is equal to 30 kilonewtons, indeed going to the right. So I guessed correctly, which means over here on this free body diagram, I'm going to say this is 30, or on this free body, I'm going to say 30. Now you don't have to draw both of these, you just need to draw one of them. If you choose to do that, that's fine. If you choose to do that, that's fine. I'm going to sum forces in the x equals 0 positive to the left, dx minus 15 minus FBE 30 equals 0, or dx is equal to 45 kilonewtons, and it is indeed going to the left. Sum forces in the y equals 0 positive upwards. That just says dy equals 0. There's nothing in the upward direction. X, 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 and only dy up. Dy's got to be 0. Yes? So over here, I can say, let's do a sum moments about A equals 0. I'll take clockwise positive. That's going to be NC times 6 minus 90 times 4.5 minus 66 times 5 plus 30 times 3 equals 0. I'm using, of course, that free body diagram. So that NC is equal to 107.5 kilonewtons. I got a positive answer, so it is indeed going to the left. Sum forces in the x equals 0 positive this way. AX minus 90 plus 107.5 NC minus 66 plus 30 FBE equals 0. AX is 18.5 kilonewtons to the left. Sum forces in the y equals 0 positive up. AY is 0. Nothing to it. Piece of cake. Questions?
Yes.
Where?
Can you just go over the NC again? I know you were talking.
Oh, I got what?
How you knew that NC was basically a roller.
Oh, I know AC's a roller, it's just NC. NC's a roller because it's just laying on top. So I've got this right here, this is a solid surface, and the beam is laying on it. Anytime something lays on something, that's a roller. I don't technically need, I could have technically put a circle there, but it's understood that it's a roller when you're just laying on top. So when your girlfriend lays on your chest, it's a roller. I just ruined snuggles for him. Snuggles have been ruined for you because now you're thinking, oh, hey, where are you going? Where are you going? North Carolina with your books in tow. Okay. Anybody going someplace exotic? Where are you going? Where? Pittsburgh. It's what? This is true, we don't have one.